This is OCR C3 from June 2009. It's question 8. The first part of question 8, we've got to give details of the pair of transformations which transform y equals log of x, that's an ln, into the graph y equals 2 log of x minus 6. Now I'm going to treat log of x here as my function f of x. And I'm going to say before I get from log of x to 2 log of x minus 6, there's an intermediate step of the graph of log of x minus 6. And in my function notation, what has happened here is that x has been replaced with an x minus 6. So this is f of x minus 6. And if you put a negative number after the x in the bracket, that has the effect of shifting that curve to the right. The minus number in here is to the right, 6 units. So the proper way of describing that is a translation. And it's a translation of 6 units to the right and none up or down. So translation vector of 6, 0. And then to get from here to here, well, I've just stuck a 2 in front of it. So over here, this is the function of 2 lots of f of x minus 6. And by putting 2 in front of a function, that stretches it vertically by a scale factor of 2. Every old height is now twice the height away from the x-axis it used to be. So writing this one down, this is a stretch, which is a vertical stretch, or you could write down parallel to the y-axis, and the scale factor of that is 2. So that's the first part of this question completed. In part B, we've got to solve an equation to find the value of point A. And point A is at the intersection of these two curves. So point A is where the log x curve and the 2 log of x minus 6 curves meet. It's where the two of them are equal to each other. To solve this equation, I think the best way forward is to bring everything onto one side. I'm going to move that log x onto the other side where it becomes a negative, so that's equal to 0. And now I'm going to play around with the laws of logs. If there's a number in front of a log, that number can appear up here as a power. So that is the same as log of x minus 6 squared. So the log is operating on the x minus 6 squared. And I will put this over here. And another law of logs say if you have log of something, take away log of something, that's the same as log of the first thing divided by the second thing. So using my laws of logs, I can write it down like that. The subtracting here meant I could divide by that x. So again, all of this at the moment is being logged. Now I want to find out what x is. So that log wasn't there, that would be brilliant. So if I just not write that log, what have I actually done to get from here to here? I've anti-logged. I've inverse logged, whatever you want to call it. I have done the operation e, if you want to think of it that way. If I remove that log, I need to do the same thing over here. So I need to do e to the power of 0. Anything to the power of 0 is 1. So I now get this equation, and there are no logs involved at all. So that's definitely a step forward from where I was. Now if I bring this x up here and multiply it by the 1, you might spot we're going to come up with a quadratic equation. If I multiply out the bracket over here, and with a quadratic equation you usually make it equal 0, so I'm going to take 1x off both sides. Numbers it times together to get 36 and add or take to get 13 are 4 and 9. Both signs need to be the same as each other. They both need to be that sign. So that means that either x minus 4 equals 0 or x minus 9 equals 0. So either x equals 4 or x equals 9. Now because I'm dealing with logs, if x was 4 over here, I'd have log of minus 2. You can't do logs of negatives. So I'm actually going to discount that answer and just go with this one here. So my answer to this is x equals 9. So that's part 2 done. So that brings me now onto the final bit, which is using Simpsons Rule. What I've got to do now is to find an approximation to an area. And if I just do a very brief or quick rough sketch, I've got a curve here, I've got a line here. I now know that that is at 9. I don't know what this is yet, but the curve here, this is to do with the curve 2 log of x minus 6. And I'm to use Simpsons Rule with 2 strips to approximate this area. Well, down here there's no height to the curve. Y equals 0 at this point. So if I change this y here to be equal to 0, now if I divide both sides by 2, I can do the same trick I did last time now. If I do e, the operation e to both sides, e and log cancel out, and over here I have e to the 0, just like before really, so that's 1, anything to the 0 is 1. So x is going to be that 1, add 6 to both sides, x is going to be 7. So I've got a 7 here, a 9 over here, told to use 2 strips, so that'll be 8 over there in the middle. So I've got this one strip's going to be from 7 to 8, one strip's going to be from 8 to 9. Simpsons Rule with 2 strips, well it's a third times by h, and h is the width of these gaps, so h here is going to be 1. Simpsons Rule is the ends, so it's usually y0 plus yn, then it's plus 4 lots of the odds, which will be y1, plus 2 lots of the evens. Well, if we look at this, if we call this here x0, x1 and x2, y0 will be the height here, yn, the last one, will be y2, y1 I'm not actually going to involve anything else, so I can ignore the bit about twice the evens. The Simpsons Rule I'm going to use is this. So what is y0? y0 is the height at x0. y0 is 0. What is y2? y2 is the height at x2. Well, at x2, x is 9. And y is 2 lots of log x minus 6. But I've just said here x is 9. So it's 2 lots of log 3. What is y1? Well, y1 is the height above x1, the height above 8. So just like this one, that'll be 2 lots of log of 8 minus 6, 2 lots of log 2. And that has to be still times by 4. So altogether for that bit, I'm going to get 4 lots of 2 log 2. I'm going to get 8 log 2 there, 2 log 3 here, nothing here. I'm going to add those together. H I said was 1, so I can ignore that. So my answer here is going to be 1/3 of 2 log 3 plus 8 log 2. And they're asking, well, it says find an approximation. You could give your answer as that, or if you type it into your calculator and get a decimal number out, you get 2.58. Either of those answers should be acceptable.